Hi all, I am K. Surya working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about resistive thermometers. A resistance thermometer is also known as resistance temperature detector or platinum resistance thermometer. It is a temperature sensor that utilizes the principle of change in the electrical resistance of a metal with respect to its temperature. As the temperature increases, the resistance of the metal increases, and this change is measured to determine the temperature. Let us see the operating principle of a resistive thermometer. The fundamental principle behind the resistive thermometer is the relationship between material's electrical resistance and its temperature. As the temperature of the metal increases, the vibration of its atoms increases, which hinders the flow of electrons and thus increases its resistance. This relationship is generally linear over a specific temperature range, and it is expressed as R of t is equal to R naught into 1 plus alpha into T minus T naught. So here R of t is the resistance at the temperature capital T. R naught is the resistance at reference temperature T naught, typically which is 0 degrees Celsius, and alpha is the temperature coefficient of resistance. The temperature coefficient of resistance is a crucial parameter here which characterizes the sensitivity of the resistance thermometer detector. It represents the change in the resistance per degree Celsius or Kelvin. Different materials have different temperature coefficients which influences their suitability for specific temperature ranges and applications. Next, we will see about the different types of resistive thermometers. So resistive thermometers are primarily classified based on the material used for the sensing element. This classified into platinum, nickel, and copper. So platinum is the most widely used due to its high accuracy, stability, and wide temperature range. So it has a temperature range of about say minus 200 degrees Celsius to 850 degree Celsius. Platinum is a noble metal, making it highly resistant to corrosion and oxidation. The standard platinum RTDs has a resistance of say 100 ohms at 0 degree Celsius. But other values like say platinum 500 and platinum 1000 are also available here. So next is the nickel RTDs. They offer a higher temperature coefficient of resistance uh, compared to the platinum, making them more sensitive. However, they have a narrower temperature range of about minus 80 to 300 degree Celsius and are more susceptible to corrosion. And in copper RTDs, they are known for their linearity and relatively low cost. Their temperature range is limited, that is minus 40 to 150 degrees Celsius, and they are prone to oxidation at higher temperatures. So next one is the construction of resistive thermometers. Uh, these are typically constructed by winding a fine wire of the sensing material around a ceramic or a glass core. This assembly is then encapsulated into a protective sheet made of, say, materials like stainless steel or ceramic. The sheet protects the sensing element from environmental factors and provides mechanical support. So the electrical connections to the RTD are made using the lead wires. So the configuration of these lead wires are say 2 wire, 3 wire and 4 wire RTDs. So the two-wire RTD is a simple configuration, but it suffers from lead wire resistance errors. Three-wire RTDs compensates for the lead wire resistance, but it assumes equal resistance in two of the leads. Most accurate configuration is the four-wire RTD, where it eliminates the lead wire resistance errors by using separate leads for more current and voltage measurements. Uh, Advantages and disadvantages are as follows. Some of the advantages of resistive thermometers are, say, accuracy, where it, especially in platinum RTDs, it offers a high accuracy and stability. Then the resistance temperature relationship is relatively linear over a wide temperature range, and RTDs provide a consistent and repeatable measurements. And also in platinum RTDs, they are highly stable and resistant to drift, and uh, platinum RTDs can also operate over a broad temperature range of about minus 200 degree to 850 degree Celsius. So these are the advantages of uh, RTDs. Uh, Next one is let us see the disadvantages of the resistive thermometers. So the current flowing through the RTD can cause self-heating, which leads to the measurement errors. Uh, and also it has a slower response time compared to the thermocouples. Platinum RTDs can be more expensive than the other temperature sensors, and it can be sensitive to vibration in some applications. So RTDs require an excitation current to measure the resistance, which can introduce errors if not properly controlled. Finally, let us see about the applications of resistive thermometers. So they are used in various applications like, say, HVAC systems, food processing, medical equipment, aerospace, automotive, weather monitoring, industrial process control, laboratory research, and so on. So hope you understood the resistive thermometers. Let us take up some assessment questions. So which of the following is the most common material used in RTDs due to its stability? So the answer is platinum. Next one is the resistance of an RTD generally increases with the increasing temperature. And finally, the RTDs are best suited for measuring temperature, which has a wide range of about, say, minus 200 to 850 degree Celsius. Thank you for watching this video.